Angela here, and this video is going to be on the experiment looking at static rotational force, basically torque. So what we have here is I'm using my SmartCart, which happens to have this thing sticking out. I'm not going to deal with it. The SmartCart is stuck on a clamp, and then at the bottom, actually I should have shown you before I put on it, but too late. There's a little bumper on it that will actually measure force. So instead of the hook that measures tension, this is going to measure force on it. And then I have a ruler, a meter stick here that's balanced on a random tube that I have. Now this holds my spectrum tubes. There's nothing in it right now. And there is a hole at this end, and so balance is not quite 500 or 500 millimeters, not quite 50 centimeters. It's actually more like 51.5 centimeters, but it is what it is. So there's our meter stick, and I have this here. It is, our force sensor is right at 71.5 centimeters. So the force sensor is positioned at 71.5 centimeters. The pivot point of this tube is at 51.5 centimeters. All right, so I'm going to, and then the other thing I'll introduce is I have a little mass here. It's a little weight. It says 100 grams on it. I'm going to double check and confirm with my scale. Let's see, now it's zeroed. And it's 100 grams. Awesome. All right, so and I have a little mass here, 100 grams. And the idea is I'm going to put this over here, and we're going to see what kind of force it applies on our force sensor over here. All right, so I'm going to go ahead and press start. So I am actually just looking at the numbers. It's up to you to pull off what numbers are important to you. Right, so this force here is the force that whatever the meter stick is doing. I actually want to ignore that. So I'm going to zero that, and we're around zero, all right? And then from there, I'm going to put the mass on my meter stick in 5 centimeter increments, getting slowly further and further away from the pivot point, and we'll see what happens to the force there. All right, still around zero? Okay, great. All right, so I said 51.5, and so I need to put this at 46.5. All right, I'm going to put this at 46.5 centimeters. So it's at a 5 centimeter distance. There we go. I'm seeing the force went up, like a quarter Newton or so. Up to you to choose an average. Right. So that's 5 centimeters distance. So let's do 10 centimeters. You can see it's a little bit wiggling there. All right. So this is 10 centimeters away from the pivot point. It's increased. Okay, let's do 15 centimeters. All right, definitely applying more force. 15 centimeters there. All right. It's jumping around, but you get the picture. All right, and then, what was that? 15 centimeters, 20 centimeters. Right here, 20 centimeters away from pivot point. Increasing significantly. Do note that this meter stick is bending a lot, which is kind of non-ideal, but we'll make do with it. We'll keep going until basically it bends and hits the table. Let's say that. All right. So that's 20 centimeters away from the pivot point. All right, let's do 25 centimeters away. Getting close to the table. 25 centimeters away. It's increased significantly. All right. Let's do 30 centimeters away. This is probably going to be the last one. Ooh, just above the table. Okay, 30 centimeters away. Going to be the last one. We're up to 1.48-ish, around there, newtons. All right. So there you go. From this video, you can pull off the data. You should get a video of what's going on with this data. I think it's in the corner up there. All right, so pull off the data of what happened at different distances away from the pivot point. What's going on with the force over here. Again, our force sensor is right at 71.5 centimeters, so it's exactly 20 centimeters away from the pivot point. Right. Yep, so take a look at that, see what happens with distance, and let me know what you think about torque. All right, I'll see you on the next video.